All right, we've talked a lot about the concepts. Let's hit the configuration. We're now going to walk through the configuration of VLANs and VTP. First off, looking at the network diagram enhancements, because we have added some switches to the network. And then we'll walk through step by step, setting up trunks, setting up VTP, getting the replication happening between our switches, adding VLANs, and assigning the ports to the VLANs. Before we jump into the configuration, let me just go over some of the changes to the network diagram that we've been making as our office has grown. You can see our corporate office, which is connected to router 1 and router 2 here, has grown to 3 switches. We have more computers than our single switch can handle, so we expanded. Now, as of right now, switch 1, which was the switch we've been using all along, has become the core switch. Essentially, everything connects to that. It's the core of our network. Now, that switch configuration hasn't really changed. I've noted the new interface connections here that will go down to our 2 new switches, switch 2 and switch 3. Now, the IP addressing for our corporate office, I went ahead and tried to shorten that a little bit. So you can see that the corporate office is represented as everything 192.168.1/24. This is the .10 of that range. This is the .11 of that range, and so on. You'll see a lot of network diagrams drawn like that just because it takes up a lot of space to write in the full IP address. Now, some of the devices still have their full IP addresses, like the hosts in this router right here, because I have some special uses that I'm going to use those for, and I'm going to be changing those as we work through this and the following videos. So that's what the landscape looks like. Now, on switch number 2 and 3, all I've done so far is just given them host names, set up some basic console port settings so that I'm able to have logging synchronous, no exec timeout, no IP domain lookup. Some of the initial optimization commands we talked about in the series. So what I still need to do is assign them IP addresses from this range and bring up their VLAN interface. Let's go ahead and do that just as a good review and get our blood flowing before we jump into the new stuff. So, wrong window. Let me bring up this one. I'm attached to the serial or the console port of switch number 2. I'm going to get into privilege mode and just do a show run. You can see as I space through this, nothing really out of the norm. Everything's looking pretty much the same as a brand new switch, no config modifications. I can do a show IP interface brief. I see some of my interfaces are up, which represents devices plugged in, but my VLAN 1 interface, which I'm going to be using for management, is currently shut down. So let's configure that. I'll get into global config mode and get under the interface VLAN 1, and we'll give it the IP address I have on my network diagram for switch 2. Look back, switch 2 is 192.168.1.11/24. Good. So I'll do a no shutdown and bring up that interface. Switch 2 is now configured. Now, with that in mind, I still need to give that switch a default gateway in order to be able to manage it remotely. I do that from global configuration mode, but I'm going to hold off on doing that. And the reason why is when we get to routing between VLANs, that's in a video or two later, you're going to be able to see some of the changes that we've made and how that may affect the routing of our network. So I'll hold off on the default gateway. Let's hop over to switch 3. Switch 3, global config mode. By the way, no config on this one as well, so I'll get under interface VLAN 1. IP address on that is 192.168.1.12. You can see that right here. Power that on, and we are good to go. So at this point, I should be able to ping between my switches. Just thinking ping 192.168.1.10, that would be pinging from switch 3 to switch 1. Hold our breath, and poof, it's working. Just that first ping takes a moment. Let's try pinging switch number 2, which we've just configured, 1.11. There we go. Success. We're now able to ping through. So we're good to go. As of right now, everything belongs to VLAN 1, meaning all of our ports. Let me just do a show command. I'll do a show VLAN. You can see this is switch number 3, default or VLAN 1. Every single one of those ports belong to the default VLAN. Notice Fast Ethernet 0/1 is missing from that list. I'll talk about why that is in just a moment. But for now, let's just go with it. Everything is plugged into VLAN 1. Now, we're moving into the configuration of VLANs and VTP. So the first step that we're going to need in all of our configurations is to set up our trunk ports between our switches. This port right here, or that link between those two, and this port right here between those two switches need to become trunks so that they can transmit all the VLAN information across them. Likewise, VTP will not work on any interface that is not a trunk, meaning it has to be active in order for VTP updates to replicate across that link. So let's first off go and configure our trunks. I'm going to start the configuration on switch number 1 because that is our core switch of our network. Now notice the interfaces. Fast Ethernet 0/11 and 12 connect down to switch 2 and switch 3 respectively. So those are going to be configured as my trunk. Now I'm going to hop on up to that switch. I got to close that window. There we go. Start off on 1. And the first thing I want to show you is that I can type in the password. There we go. First thing I want to show you is how those ports are configured by default. I'm going to do a show run fast, or type in interface fast Ethernet 0/11. That's just a way that you can trim down the running config to show just that interface from it. I hit enter and you can see the default mode of that port. It says switch port mode dynamic desirable. As a matter of fact, let me just do a show run. Scroll down a little bit. Look at that. 0/2 dynamic desirable. 3 dynamic. Everything is dynamic desirable. That is a horrific default. Let me tell you why. What that says is this switch port is in a mode of dynamic, meaning, let me jump back here, it can either become an access port or a trunk port on the fly. Now, access ports are designed to connect to NPC. Anytime you have a PC device right here, it needs to be an access port, which means essentially means it's not going to be a trunk. Meaning I can assign that to one VLAN, it will always be on one VLAN, we will not negotiate a trunk connection. The trunk ports are used between switches, and that is the one that transmits all VLAN information between the two switches. Now, the default, again, is dynamic desirable, which means I will dynamically switch between these two modes. If I detect another switch plugged in, I'll convert to a trunk port. If I detect a PC plugged in, I'll convert to an access port. Now, it sounds convenient, and that's why Cisco designed it that way. They wanted it to be convenient, so you could just plug cables together and be trunking, which is actually what we're doing right now on these ports. They are trunk ports because we're dynamic. They're just switching to whatever's plugged in. But the reason I say it's horrific is because it's wide open to malicious people. Let's say that this person in their cubicle is an angry user, and he does not like the company at all. So he brings in his own switch from home and plugs it into his cubicle wall jack. Well, as soon as he does that, the switch will notice that and go, oh, well, hey, let's negotiate a trunk connection with that other switch. VTP updates will be sent down that port. The user can actually sabotage your VLAN database. They can use an attack known as VLAN hopping. I'll talk about that a little bit more. So it's horrible to have those ports on dynamic. Anytime you see anything like dynamic, desirable, auto, negotiate, anything like that on a Cisco device, it's usually better, 90% of the time, it's better that you would hard code those modes rather than leave them on dynamic. So dynamic desirable means I'll dynamically change and I'm desiring to be a trunk port, meaning I will actively negotiate a trunk if I see another switch attached. So our two ports that we're configuring are 11 and 12, and I need to go under those ports. I'll do interface fast Ethernet 0/11, and I need to change the switch port mode. Type in switch port mode, and I'll do a question mark, and you can see we have access, we have trunk, and we have dynamic. .1Q tunnel, that's another story for another day. That's actually a CCIE level topic right there. But access and trunk are the two we want to use. Right now it's set to dynamically negotiate. Now this is a connection between a switch, so we can safely say switch port mode trunk. Now this is going to give an error when I do this, and it's saying the command is rejected. An interface whose trunk encapsulation is auto cannot be configured to trunk mode. Here's what that means. Remember I said there was the language of love. That was in the previous video. The language of love of trunking was 802.1q. That is the official trunking language that everybody in the world now uses between their switches. But long ago, when VLANs, the concept of VLANs were first created, Cisco created their own trunking language. It was actually known as ISL, Inter-Switch Link. It was before the 802.1q standard was really standardized and really was a good standard to use anyway. So Cisco said, we're going to create our own, and you can use that between Cisco switches for more efficient trunking. Well, times have changed, the industry has progressed, and ISL is being faded out. And what I mean by that is it's going away. They're trying to phase it out of all the switches. A lot of the brand new switches they create don't even support ISL. However, this switch, switch number 1, is actually a 3550, which is a little higher end switch, supports a lot more features. So it has the ability of using ISL or 802.1q on its interface. Now, so what it's saying is the trunk encapsulation right now is auto. It's going to try and negotiate between the two, which kind of integrates with this dynamic system. But since we're hard coding everything, we have to add an extra command to the upper end switches in Cisco's world. And we type in switch port trunk encapsulation, and then we choose 802.1q, or they write it .1q, ISL, or negotiate. Now remember, anytime you see negotiate, dynamic, auto, don't use it. We are going to hard code .1q. Now that we've hard coded what language it's going to speak, the language between the switches, I can just type in switch port mode trunk. Enter. And now you can see the same command as before, but now it's not popping up that error message between the two switches. So we have, on the 3550, Fast Ethernet 0/11 is configured as a trunk port. Good. Now let's move over to Fast Ethernet 0/12. And this should be pretty simple. I'll just type in switch port trunk encapsulation .1q, enter, and then switch port mode trunk. Good. So now Fast Ethernet 11 and 12 are both configured as trunk ports, and let me show you a massive security step forward in your world. Now that you know which ones are trunks, set all the rest of them to access ports. Meaning right now, everything else, these two are hard-coded trunks, but everything else is still set to dynamic. So this is a 24-port switch, so we can safely say 1 through 10, up to 11 is considered an access port, and then 13 through 20, let's do 23. There's something in this picture I'm not showing you. I'll show you a little bit later. 13 through 23 will be considered access ports. So here's what we do. You can type in interface range Fast Ethernet, and then you type in your module and port 0/1 through 10. I'll do that first group, and I'll say switch port mode access, or full command access. I'll then type in, hit the up arrow, and do interface range Fast Ethernet 0/ and then what was the next range? 13 through 23. 13 through 23. Switch port mode access. Hard-coded access ports. Good. Now if I go back and do a show run, you can see that all of the modes have gone over to access. This is our internet router connection. We labeled that in the first video. But Fast Ethernet 2, access, access. Good. All these are great. Oh, there's our trunk ports, trunk and .1q encapsulation. Everything else, access, access, access. Because we want to make sure that they don't negotiate trunk ports on the fly. Good. So we've got the core switch, 3550, configured. Let's go down and do switch 2 and switch 3. I'll do these a little bit faster. Jump over to switch 2. Now, switch 2 and switch 3, I'll do a show version, are actually Cisco 2950 switches. They don't have as many features as the 3550, and one of the features they're missing is the ability to support ISL encapsulation. That's not even an option on the 2950. It's been phased out. They only support 802.1q. So when I configure the trunk ports on switch 2 and 3, you can see the trunk ports are Fast Ethernet 01 and 01 on both of those. All I need to do is get underneath the interface Fast Ethernet 0/1 and type in switch port mode trunk. Enter. There is no encapsulation command. Look at this. I'll type in switch port, trunk, encaps, there's no command. Notice, I'll hit the question mark. Nothing. No encapsulation command because since it only supports one encapsulation, 802.1q, what's the point of having others? Now on this switch, I can safely exit back out and do interface range fast Ethernet 0/2 through 24, meaning all the rest of the ports except port 1, which is our trunk, and type in switch port mode access. Slam. All those are now access ports. Do a show run. And you can see there's my trunk, 0, 1, 2, 3, 4, and everything else is now considered access ports on this switch. Let's go do switch 3. Fast Ethernet 0, 1, switch port mode trunk, and then interface range fast Ethernet 0/2 through 24, switch port mode access. Now if you're following along, if you've got your own lab equipment and you're setting up this kind of configuration, I do want to make sure I mention the interface range command on most iOS versions, except the very newest and best iOS versions, is really finicky with how you type this in. The spacing has to be exact between these two. So if you forget a space, exit back out, interface range, fast Ethernet 0/1 through 10, it'll say, I don't know what you're talking about. In the new iOS versions, they fix that so it works real seamlessly. But I've seen a lot of people that are like, oh no, I can't use the range command. My iOS must not support it. Most of the time, it's just looking for a different syntax there. Good. So I would say it's safe to save our configuration, if you type it right, on all these switches. We've got our trunk ports configured. That was step 1. Step 1. So let me clear off all the chicken scratch here. I'm going to be updating these diagrams as we go through to reflect our changes as we go. Now, in this video, I'm just going to be drawing and adding things by hand, but I'll modify it in the background later so it looks much prettier. So the trunks are configured. Now let's do the second thing. Configuring VTP, the VLAN trunking protocol, so all of our VLANs can replicate between the two. So, and actually looking at the time, I think we're going to do the first 2 steps in this video, and then we'll split it and do the last 2 steps in the upcoming video. I don't want to make this too long. VTP, just to hit the highlights, replicates those VLANs between our switches. We talked about that in the previous video. Now again, let's start up on our core switch, switch 1. And I'm going to type in the command, show VTP status. That command will show you everything about VTP. Now, I will mention that all the things that we type for VTP are not stored in the running config. They're actually stored in another file. Again, I'll talk about that as we get deeper in this. But as of right now, you can see everything about VTP. It says VTP version is currently running VTP version 2. The configuration revision is revision 1, meaning there's been one change made to the switch because they start from 0. That's interesting to me because I don't know which change that is. Let me jump down to switch 2 and do a show VTP status down here. Okay, there must be something on our core switch. Oh, I just remembered what it was. I'll tell you about that later too. Let's look at switch number 2 that in the changes that we have here. VTP version 2, config rev 0, meaning there's been no changes made to this switch at all. Maximum VLAN supported locally is 128. That means this switch, this 2950, supports a maximum of 128 VLANs passing through it at one time. Now, the VLAN numbers, you can have up to, the VLAN numbers go 1 through, I believe it's 4,094 maximum VLANs that you can have on your switches. But these lower-end switches only have 24 ports, so they're saying, why would I have 4,000 VLANs and support that many active VLANs when I only have 24 ports in the first place? So, and you can see the bigger you go on the switch, like this is a 3550 up here, the more VLANs you can support. Now down here it shows the number of existing VLANs is currently 5. Now that means there are currently 5 active VLANs on here at a time. Now wait a sec. I thought there's only VLAN 1. Let's do a show VLAN. Now when I do that, I see that I have VLAN 1 and then look below it. We have VLAN 1002, 1003, 4, and 5. Those are considered extended VLANs. They were created to support other kinds of networks, like you can see token ring networks and FDDI, that's an old fiber optic standard networks. Now, in order for a switch to be considered industry compliant or standards compliant, those VLANs have to be on there. So it's not like we're actually using them. Matter of fact, you can see the status is that they're active, but they're unsupported because this switch doesn't have any token ring interfaces or FDDI interfaces. So they're just there because the standards say they have to be there. But we're really only using VLAN 1. So you add them up, 1, 2, 3, 4, 5. There's our 5 VLANs that it's seeing in that show VTP status. Now down below you see the operating mode. It's currently a server because everything is a server by default out of the box, and the domain name is blank, meaning there is no name for the existing company or the replication that's happening between them. So let's stop there and jump into our configuration. When we're setting up VTP, we need to configure 3 major aspects. One is that VTP domain name. I'll just put name. 2, if we want to, and this one is optional, we can add in a password for the VTP domain. And 3, if we want to do it, we can change the VTP mode. Remember the 3 modes, server, client, and transparent. So we can choose which mode we would like to create. So let's start off with number 1, which is configuring the name. To set that up, I'm going to jump back to our main switch in the network, which is switch number 1. Now before I do that and get the command prompt pulled back up, I want to make a mention of something that will happen before your very eyes. It's a magic show. On this switch, when I configure the domain name, and let me just come up with it. I'll use Nugget World will be my VTP domain name. When I configure that domain name on switch number 1, switch number 2 and 3 will automatically pick it up, meaning they will automatically join the Nugget World domain. Now, the reason that's going to happen is because as of right now, if you look back, switch number 2 and switch number 3, we didn't do this command on 3, but it's there, do not have a domain name, meaning they are not a part of a domain. And when a switch does not have a domain name, it is in the most susceptible state to VTP that it ever will become. And that is in a state where it will take whatever domain name is first advertised in. When we go on switch number 1 and set the domain name to Nugget World, it will send it out all trunk ports and say, hey, I'm Nugget World. Switch 2 and 3, since their domain name is blank, and let's just jump over to switch 3 just to make sure. There it is. You can see right there. The domain name is currently blank. Since it's blank, it will adopt whatever domain name first comes to it, and it will become part of the Nugget World domain. Now, once that happens, once it is a part of a VTP domain, it will not change ever again unless you change it manually. Like maybe you want to have switch 2 and 3 a part of a different VTP domain. Well, you could go in and manually change them, but that will not affect anybody else because they've already have a domain name assigned. Cisco set it up that way, so you could pull a brand new switch out of the box, no configuration on it, plug it in, it's dynamic mode by default, so it negotiates a trunk, receives an update, and automatically gets all the VLANs that are in your organization. Kind of handy if you like the dynamic way of things. So let's jump on to the switch number 1. The way that we set our VTP domain is to go into global config mode and type in VTP, and I'll do a question mark, domain, and it says what is the name. Type in Nugget World. Now this name is absolutely case sensitive. So if you use capitals or lowercase on one switch, make sure you do it on all of them or else it won't replicate. So I type in Nugget World. It says I am changing the domain from null to Nugget World. It's changed. So when I go back and do a show VTP status, I can see that Nugget World has popped up here. Now I jump down to switch number 2 and 3. Let's see if what I said happened. You can see right there, they adopted Nugget World as their VTP domain. Let me just hop over to switch 3. Nugget World. Excellent. Now you can even see down below the last local updater. Who was the last one to update this. As of right now, it just says the local updater ID was this, 192.168.1.12, or this, which is 192.168.1.11. All that means is that it was itself. The configuration was last modified by itself in 1993. Obviously, I need to change the date to make that right, but that was the last modification that was made. So we've got VLANs, or sorry, the trunks configured. We've got VTP configured. Oh, I said I was going to cut this in half. I'm not going to do that. I'm going to jump down to step number 3. Maybe I'll divide it after this, because VTP without creating VLANs is kind of like, that's not exciting. So what I want to do is I want to set up some VLANs and watch them replicate. Oh, wait. I'm just jumping all over the place. We've got the name set up. We've got no password, and let me show you if we wanted to set up a password, how we do that. Type in VTP, and you can see password is one of our options. If we wanted to assign a password, we could. I'm going to skip that step just because you just type in a password up here, and then you'd have to go to switch 2 and 3 and type the same password. It's pretty self-explanatory. But what I do want to show you is changing the mode. When you type in VTP mode, it gives you those 3 options that we talked about in the previous video: server, client, and transparent. Now remember, everything is a server by default, so anybody can add or delete VLANs and they'll replicate to everybody else. You're supposed to only have 1 or 2 servers in the network, and everything else will be clients, which means the client cannot add or delete VLANs. It just accepts updates from the other switches. VTP transparent mode is the Harley-Davidson Rebel switch that maintains its own list of VLANs and does not send them out, nor does it accept updates from other switches. So switch 1, since that's our core, let's make that the server. Let's hop down to switch 2, and I'll type in VTP mode client. Do a show VTP status down here. And now you can see the operating mode is client. It's still in the Nugget World domain. Now, that's a good point. Notice right here, it says the configuration last modified by 0000, meaning nobody's last modified the configuration. Do you remember when we did this command before? It said local updater ID is this. That was on there before because it was in a server mode, and it said I can update myself. But as soon as I changed it to a client mode, scroll back down, you can see local modifier ID is gone, meaning I can't locally modify the configuration anymore. And let me do switch 3, and I'll prove that. I'm over on switch 3. I'll type in VTP mode client. Boom. It's now in client mode. And verified, right there it is. Now let's hit this last piece, which is configuring the VLANs. In the next video, I'll assign the ports to the VLAN. To configure the VLANs, all you need to do, it's a piece of cake, is go into global config mode and type in VLAN and what VLAN number you would like to create. So I could say VLAN 10. Enter, and that will create the VLAN. But I want you to catch this. I'm on a client right now, so when I hit enter, it says, oh, sorry, VLAN configuration is not allowed when the device is in client mode. You can't do that from here is what it's trying to say. Now, this is where you as an administrator have to exercise self-control because this is the suggested design. We have clients everywhere in the network. One server, 1 or 2 server maybe as a backup, and that's where you make all your changes from. So it's tempting when you tell that into the wrong switch and you type, oh, I just want to create this VLAN. It says, oh, you're a client. All you have to do is type VTP mode server to switch it back and make that change, but that's not how it's supposed to work. So let's hop back up to switch number 1. I'm already in global config mode. So I'll type in VLAN 10. Enter. Now it takes me into a VLAN creation mode or a VLAN config mode. VLAN 10 is actually created. If I go back into a show VLAN, you can see that VLAN 10 has now appeared in my list. See that? And then if I want to, I can go in and say, go back under VLAN 10 creation mode, and I want to say the name of that VLAN is sales. Enter. A lot of people, and most people, will assign names to their VLAN because it's a lot more logical to see, oh, that's for salespeople or the marketing people or the internet router or whatever the case may be, so that you can notate what that domain really is about. So I'll do a show VLAN again. I can see VLAN sales is now in the list. Let's do a show VTP status on our server. You can see the configuration revision has gone up to 3. Let's jump down to switch number 2, show VTP status down here. Take a look at that. It's hopped up to 3 as well. And notice what changed. It says the configuration was last modified by 192.168.1.10. So who is that? Let's hop back up to our diagram. That's switch number 1.10. So it sent an update that modified the configuration on switch number 2. Let's do a show VLAN here. The power of VTP in action. Let's go over to switch number 3. Show VTP status. I can see that the config was last modified by switch number 1 right there. Configuration rev, that should be the same on all of them because remember, the revision numbers work. That's how it finds out it has the latest copy of the database. We talked about that in the previous video. Show VLAN and you have to make that noise. Sales. Sales is now shown up. So here's what I want to do. I want to create 3 VLANs. So let's head back up to switch number 1. I'll create VLAN 20. Name, marketing. VLAN 30, name, engineering. Show VLAN. There we are. We've got the 3 new VLANs that have come up there. A nice little status message to make it all jumbled. But the 3 new VLANs are there. I'll do a show VTP stat. You can see our config rev has gone up to 5, reflecting the 2 new VLANs that we just added. It went from 3, 4, 5. And now we can hop down to switch 2, show VLAN. Switch 3, show VLAN. So there they all are. They are all showing up because VTP is working correctly. Now keep in mind, this whole time, we've been making all these changes, configuring trunks, setting up VTP, configuring the VLANs, but nothing on our network has changed. Meaning, we're setting up VLANs, and I'll just write them up here, VLANs 10, 20, and 30, but no ports are actually assigned to those VLANs yet. So, if I'm looking at my computer, I'm sitting right here on 192.168.1.50, bring up a nice little command prompt, that's my PC, and I'll ping over to 192.168.1.20. I'm still able to ping there because these ports are still assigned to VLAN 1. If you look back at our config, this shows the VLAN. This shows all the ports right there that are assigned to VLAN 1. Yes, we've created the VLAN, but we're not actually doing anything with them yet. So that's what I plan on doing in the next video, is assigning those ports to the VLAN and then testing the effects of that, showing what happens when we do that. Now, before I do that, before I wrap this one up, I want to talk about Fast Ethernet 0/1. Notice it's missing from the list. The reason why is because it is configured as a trunk. I want to show you a new command here. Well, first off, I'll do a show run interface Fast Ethernet 0/1 just to verify that is a trunk. I'm going to type in show interface Fast Ethernet 0/1. And we've seen the show interface command before, but I want to add another command, which is switch port. Remember the commands we used to change the mode from trunk to access and all that? It was switch port mode. So this shows the switch port mode characteristics, and I can see that the switch port is enabled. It is administratively set to a trunk. It is operationally at a trunk. The administrative encapsulation is .1Q. The actual operational trunk encapsulation is .1Q. Now, first off, let me just explain. What's the difference between administrative and operational? Well, you remember when we first got on the switch, it said switch port mode dynamic? That was the administrative mode. It was dynamic initially, but we changed it. So if it was dynamic and it negotiated a trunk, we'd see administrative, dynamic, operational, trunk. Or we might say administrative dynamic, operational access, that kind of thing. But if you look down this list, you can see the native mode VLAN. We talked about that in the previous video. A lot more information on here on trunking VLANs enabled. That's what VLANs it's sending across there. Pruning VLANs enabled if pruning is turned on. And by the way, VTP pruning. That's how you turn on the pruning aspect. I talked about that in the previous video. You just type it in and hit enter. So those are all verified by using the show interface, what one you want to look at, and switch port to see the trunking status. We can also type in show trunk. No, we can't. Show. There's a command. Show interface trunk. There it is. show interface trunk will show us that we've got fast Ethernet 01, mode is on, encapsulation, status is trunking, native VLAN is 1. So you're able to see which interfaces are set to trunking by either typing in show interface switch port, where you can see them all, or you can do just show interface trunk for a lot more concise view. That's where I want to draw the line for this video. I know there's only one more step, which is assigning the switch ports to the VLANs, but there's a lot of testing I want to show you and show you the effects of what happens when we do that, so that you can have a full scope of what's going on. We'll continue that. I'll make a part 2 to this video. So we walked through this and saw the network diagram enhancements. We added 3 switches to our network, or 2 additional switches, and we assigned IP addresses to them. We then configured VTP, and in order to do that, we had to set the trunk ports between the switches, turn on the VTP domain name, and set all the parameters with VTP. Then we added 3 VLANs, VLANs 10, 20, and 30, and watched them replicate between them. In the next video, I know it's just one step, I'm going to show you assigning the switch ports to the VLANs and then the effects of what happens when we do that. Also, we'll look at a lot of the administrative considerations of when you do create multiple VLANs, how you